Assalamu alaikum. Today I will show you a servo motor that can be controlled by potentiometer. I mean the speed of the servo motor can be controlled by the potentiometer. I am connecting and then we'll explain. Okay. In general, I have indicating that the green sorry, red is this voltage. I mean red is connected with the 5 volt point with the microcontroller, and the black is ground, and green and blue is used to communicate. Okay, they are giving or taking signals. And then there comes that at first you need to understand the structure of this breadboard. Okay, how can you understand? If I just zoom in, it does fine. Okay, let's hold my cursor in any of the hole or pin. You see that like this. If I have put my cursor here, all of this has become green. That means all the points are same electrically, or I can say that all the points are short like this. So if you connect in this point, the message it carries. If you made point, if you connect something in this point, it will carry the same message. For the same time, for the same explanation for all of these points. But if you just click in, you will see that these are similar, and in here these are also similar. Okay. But if you put your cursor here, you see that this is horizontal line. The points that are pointed horizontally, that are same or similar point. For this case is also same, and this is also same, and this is also same. This is the simple something that you need to understand about the breadboard, otherwise you may feel problem. And if you forget what is the same points, then one thing can do in the real world whenever you want to work with this, you see that in the back side of this breadboard, you can it is covered, okay, and it is like attached with glue, so you can pull it out and check where which connections are short, and then put it back. This is also a good way, but not legal way to understand the connection. Okay, and let's come to the point. Okay, and then oh sorry, okay, let's come. I am showing that the 5 volt, 5 volt, it is connected to this point, and the ground, this ground block, this is connected to this point. Okay, and then I have ensured that all these points, okay, I have ensured that all these points are same for the 5 volt. All this point carries 5 volt, and this all these point are ground. So I don't, for the use of breadboard, it is not necessary to connect uh, this ground, I mean the ground of this servo motor with the ground of this microcontroller, or the ground of this potentiometer with the ground of this microcontroller. Okay, it is giving us what can I say, more convenient connection process. And then here comes the that's why, as all of these points carries the 5 volt, and all of this current point carries the ground, so I have just connected the potentiometer with here, and it giving the message, or it means that it is connected to the 5 volt of the microcontroller. And then I connected it to the ground, and for the same case, the same explanation for the servo motor as well. And then here comes the points, or the pin that will use to communicate with the microcontroller. For servo motor, I have connected this with A0, and the sorry, potentiometer, and for the servo motor I have connected it with A4. And you need to understand that here we will take the analog values. So as you are dealing with analog values, so definitely you have to use the A0, A1, A2, A3, this type of pins, where the A means analog, okay, where these types of pin have to be taken. And similar case for this, as I will control the speed, then I definitely have to use the analog pin. Digital means 0 or 1, either stop or run, or like for motor, either stop or rotate. Or rotate, then you have to understand it will rotate as full speed or not. Okay, so this is 0 or 1. These two steps are only available in digital, but in analog, each and every what can I say, point can be uh, taken or given. Okay, I think it's simple code you have understood, and now I will go for the code. Here comes the code, and I will try to make you clear what the function of the each and every line of this code. But one thing I want to, that this code will be uploaded in my GitHub, and if you want, then you can copy that, and you can play with this. Okay, at first time, for the include servo.h, this means that I am taking the header file so that I can communicate with the servo. Okay, and then servo, my servo, this is a name, and what type of object will be stored, this is servo. If I want to clarify this, if you have if you are familiar with C programming, then you may heard that int a means a is a variable, and what type of data will be stored here, integer type. So int represents its type, and a is the variable name. It's the same case. This is servo, my servo, and my servo represents its name. Whatever data will be dealt with, that is servo. And the constant int pot pin and constant servo pin. You can omit these two lines, and if you don't write these two lines, then whenever in this upcoming code you will see the pot pin, you just need to A0. Whenever you will see the servo pin, you will say that A4. That's it. Let's come to void setup. I have explained earlier, definitely, that the void setup is the place where you need to set, or you need to indicate about the components or something like that. I mean, what you have to do for one time only in your code, enter code, then that should be placed in setup. But what you have to do time and again, have to repeat, then have to do a void loop. And come on, my servo dot attach servo pin. In this command I am saying that to the servo pin means A4. Okay, if you don't write those two lines, you direct can write A4. So that means I am saying that the servo motor is attached for the communication. The pin is A4, and my servo dot write 0. That means initially the angle of the servo motor will be 0, and then it comes the void loop. Void loop means void int pot value is equal to analog read pot value. It means it's again f, as I have said earlier. A, that means variable name, and whatever variable it will deal with, that is integer type. This is the same case. The pot value here is definitely, you can see I have taken earlier. The pot value, this is a variable name, and integer type variable will be stored here. So what is exactly gonna be stored here? Analog read pot pin. That means if whenever I will rotate this, sorry, now it will not work because it will not, I haven't started simulation. So here, so oh shit. So whenever I will rotate this, due to the rotation it will change its place, and then it will, in each and every certain what can I say, change, it will provide, or it will give a signal to the microcontroller, and this signal is set to read by analog read function, and then it is directed to store this in the pot value. And then here comes the int speed delay. Okay, here come this is actually called mapping, mapping. So if you, it is another explanation, that is speed delay, and speed delay variable, and whatever data it will restore, it is integer type data will be stored here. And mapping is something sorry, a mathematical concept, you can say, like 0 to 5, and then I think it will be easy for you. What does this line means? This line means that when the value of the potentiometer will be 0, then the voltage will be 0. When the potential value of the potentiometer will be 0, 1023, this is the highest, and then the voltage is 5, that is highest. Okay, like it's like in Bangla that is called oikik niyam. Okay, when the value will be 1023, then the voltage will be 5, and then you can calculate the voltage for each and every single analog value. Okay, so in this way, the for the analog value, we can calculate the corresponding value voltage, and using this voltage we decide, or we rotate servo motor. And then here comes a loop, for loop. Again here I'm not going to I think I don't need to explain this, what is said here. for as it is for loops, integer, angle 0 and angle, I think it's gonna be good if I said 180. Okay. And as you can see that and earlier I have said that here that whenever the initialization would start, the angle of the server will be 0. So here in the same case, at first it will start from the angle 0 and is checking is the 0 is the angle is less than 180. Yes, that is. So come here, servo motor to the right. This means the servo motor, it is saying the servo motor to rotate to this angle. So 0 angle, it was in 0 angle. I am also saying to rotate in 0 angle, so it will not rotate. And then delay speed. Okay, again it will increase one angle, and then it was 0 and now 1. Come here, is what checking is 1 is less than 180 degree, definitely yes. Come here, and then servo dot right angle 1, that means it was in 0 degree angle, now 1 degree angle, so it will start to rotate, and then continuously it will rotate up to 180 degree. It will be 181, 181, not a 180. Okay, 181. It will break this condition, then this will not be followed, and our code is finished. So that's how the code works actually. Let's simulate and see the game. You can see that it is here. Okay, it is rotating in a suppose a certain speed. Okay, this is the minimum point, I think. Yes. And then if I increase the velocity, if I increase the angle, I'm expecting that the velocity will be increased, and you can see that. And again, let's do this. You can see it's rotating in a smooth way, but here it seems that it is in a hurry. And if it is okay, that's how our code and simulation works. I think you have got the point. Thank you for watching this video and keep motivating us. Thank you. Assalamu alaikum.